implicit differentiation in the product rule. So between the x and the y is not a plus, it's a times, so we can't just split them up and do the derivative of x and then the derivative of y. It's not that easy. Remember the derivative rule, y dash equals v u dash plus u v dash. That's the one we're chasing here because y was equal to u times v. That's what we're thinking here. So let's just set u equal to x and v equal to y. So we're going to go this way. U dash is 1, v dash. What's the derivative of y with respect to x? To y dx, because it's implicit. Let's just do this rule in our head. So we're going to get v u dash plus, so the derivative with respect to x will equal v u dash plus u v dash. So our derivative of that, d dx of xy, will equal x dy dx plus y. Looks very strange, doesn't it? But that's what it is. Okay, we're going to apply that product rule here. So you can see from last video that these things here don't pose a problem. But that's an issue because that's a product in between the x and the y. So the derivative of 3x squared is going to be 6x plus. I'm going to have to apply the product rule. The product rule gives me two terms. So just in case this is a negative, I really want to put in some brackets. Let's leave that till the end. Have I got a big enough bracket there? Parentheses, I guess. What's the derivative of that? It's going to be plus 12y squared dy dx, and the derivative of 17 is 0 equals 0. So I guess I can squeeze it up here. I'm thinking here, u is 2x and v is y squared. U dash is 2, v dash is 2y dx. So the rule, v u dash, so it's going to be v u dash plus u v dash. Because that's a plus, the parentheses really didn't make a difference, but please use those brackets just in case that thing there is a negative and we need to distribute that negative. That would be a classic external exam trick for you. Okay, so let's just neaten this up. 6x plus 4 clearly we've got these two terms with dy dx in it, so we need to factorise for xy plus 12y squared, and I want to get these other terms without the dy dx over to the other side. We've lost sight of the question already. Dy dx will equal, there's probably a factor of 2 there, isn't there? So let's go minus 3x minus y squared on 2xy plus 6y squared. There we go. Done. Not really all that hard, but please have your radar out for these y's, implicit differentiation. Please have your radar out for the product there. The product rule can just trick you up, so don't rush, take your time. Okay. This one's okay, look at that. There's only one implicit and it's actually a product rule all at the same time. So this should be a quick one. 2x plus, don't forget your brackets just in case that's a negative, minus 6 plus 0 equals 0. Okay, so u equals v equals u dash v dash dx. Okay, so it's going to be v u dash plus u v dash. Because that's not a negative, let's just get rid of those brackets. Then all we need is this dy dx. So let's just go 2y, 2x squared y. And let's get everything else other than that on the other side. So that'll be 6 minus 2x minus 2xy squared. I don't know why I did that on the line above. I guess I knew because I was getting this to the other side. But anyway. Can you see there's a 2 here? So let's make that 3 minus xy squared on x squared y. There we go. So once you get the hang of it, it doesn't really take much for it to pop out. Please practice, practice, practice.